Algebra 3, Chapter 1, Section 5, Complex Numbers. Now we've seen there are quadratic equations that have no real solutions. Solving them results in the square roots of negative numbers. To overcome this problem so that they actually do have solutions, mathematicians created an expanded system of numbers using the imaginary unit known as I. The definition of I, well really I squared, is that I squared equals negative 1, which means that I itself is the square root of negative 1. When we combine this unit with real numbers, we have the set of complex numbers. Complex numbers are in the form a plus bi. A is the real component, and bi is the imaginary component. Now, a real number can be written as a complex number in the form of a plus 0i, so all real numbers can be written as complex numbers. A pure imaginary number can be written as 0 plus bi. If a plus bi equals c plus di, then a equals c and b must equal d. To add or subtract complex numbers, we're simply going to combine the real parts and then combine the imaginary parts. So for example, a plus bi plus c plus di equals a plus c plus bi plus di. Subtraction works the same way. Just watch that negative. Make sure you distribute it. When you multiply, you treat I kind of like you would a variable. You distribute or you use FOIL. But remember, it's not a variable, and I squared equals negative 1. Here's an example. Try this problem, pause the recording, and resume the recording to check your answer. The first thing we want to do here is we want to split up our numbers. We have the real and we have the imaginary. We also need to make sure that we write the square root of negative 18 as I square root of 18. And then we're going to break the square root of 18 down. It is 3 times 3 times 2. We have a pair of 3s, so they get to come out with the I. And we have 3i square root of 2 minus 3i square root of 2. And that results in 4, because 3i square root of 2 minus 3i square root of 2 cancel each other out. Here we have another example. Perform the operation and write the result in standard form. So we have 12i times I minus 9i. So what we're going to do is we're going to distribute. And that gives us 12i minus 108i squared. Remember that I squared is negative 1. So we have 12i plus 108. However, this is not in standard form. You need to put the 108 first and the 12i second. Okay, you try this example, pause the recording to do it, and resume the recording to check your answer. So our final answer is 11 minus 41i. Again, pause the recording, try this example, resume the recording to check your answer. Okay, we FOIL it out, combine like terms. Remember that I squared is negative 1. And our final answer is negative 13 plus 84i. Oh, getting a little tricky here. Try this one. The I again is actually outside of the square root, not inside. It's a little weird when it's written this way. Personally, I prefer it to be in front of the square root. However, our book will often write it like this, so we do need to get used to it. But when you see an I, it's like this. It's outside of the square root. Okay, FOIL this out and see what you get. Pause the recording to try it. Okay, we notice that our square roots went away, as did our i's. This is a special case. What we're doing here is we're multiplying the conjugates together, and when that happens, we lose both the square roots and we lose the I. Our final answer is 18. Okay, this is talking about what we just looked at. A plus bi and a minus bi are called complex conjugates. Whenever you multiply them together, the result is a real number, as we just saw in that last example. In order to remove an imaginary number from a denominator, we're going to multiply the numerator and denominator by the conjugate of the denominator. This is exactly what we do with square roots, and since I is the square root of -1, we're really just following that rule that we don't want to leave a square root in the denominator. To find the complex roots of a quadratic equation, you must use the quadratic formula or you must complete the square. All right, try this example. You're going to write the complex conjugate and then multiply the number by it. Okay, so the conjugate would be 9 minus 2i, and when we multiply, we get 85. Okay, pause the recording and try this example. Remember, you want to remove the I from the denominator, so you will need to multiply both numerator and denominator by the complex conjugate. There we're multiplying top and bottom by 4 plus 5i. And we distribute on the top. We use FOIL in the denominator. We remember that I squared is -1, and we end up with 8 plus 10i over 41. Now technically this is not in standard form. Standard form, we need to actually split it up and make it 8 over 41 plus 10i over 41. Okay, let's try this example. I want you to try this on your own. Now, before you find the common denominator, you need to go ahead and take care of the i's in the denominator. So you want to, for both of these fractions, get the I out of the denominator. That's actually going to make your life easier because it will give you a single number for each denominator and make finding a common denominator easier. Pause the recording and give this a try. And as you can see, we ended up with the exact same denominator, which is very convenient. And again, our final answer to really be in standard form should be 12 over 5 plus 9i over 5. Let's try another example. Pause the recording, give it a try, and resume the recording to check your answer. Okay, we went ahead and multiplied both fractions by the conjugate for each, and we ended up with two different denominators this time, 13 and 73. The common denominator is actually just going to be 13 times 73, so you see where we did that here. 13 times 73 is 949. We made the numerators, adjusted them so that for the new denominator, and combined like terms. And again, you would need to split this up into 279i over 949 plus 62 over 949 to truly be in standard form. And you do need to put the 62 first because the term with the I needs to come second. All right, let's write this complex number in standard form. Now I'll give you a little hint. You must rewrite these as I times the square root of 5 times I times the square root of 10 first. Pause the recording and try this. Don't forget to, we need to break down the 50, and I squared is I, or is -1, excuse me. I squared is -1. So we have -1 times 5 square root of 2, or -5 square root of 2. And there on the right, you see how we broke down the 50. All right, here's another one. Again, you need to change the square roots. You need to pull the I out front first. Then you can go and do the operations on them. Pause the recording and give this a try. The I's come out first. Then we FOIL and combine like terms. And you'll notice we really, this is about all we can do. Example, All right, this time we're going to use the quadratic formula to solve this equation. You should be very familiar with the quadratic formula. Had you learned it last year to the tune of Pop Goes the Weasel. So sing it a little bit if you have to while you're working the problem. Pause the recording, give it a try, and resume the recording to check your answer. Okay, and our final answer, to be truly in standard form, would be that second answer, 1/3 plus or minus 2i.